All right, folks, welcome back to the lesson on special right triangles. This will be the second of two videos, and we're going to talk now about the 30, 60, 90 right triangle. In the previous video, we talked about the 45, 45, 90. Remember that? Where you have your old congruent legs and square root of 2 hypotenuse. Well, we're going to learn about another special right triangle called the 30, 60, 90 right triangle, and it is a lot of fun. And by fun, I mean, well, we'll find out. So let's take a look at the note. Oh my gosh, Mr. Katz, this is too much. I know. So this is the 30, 60, 90 triangle theorem, where you have the length of the hypotenuse is twice the length of the short leg, and then the length of the long leg is root 3 times the length of the short leg. Got it? Great. Piece of cake. Video over. Good luck. Just kidding. So this does require practice and familiarity, and I'll give you a couple examples on just right here on this note. So like I did in the previous lesson with the 45, 45, 90, let me first break this triangle down into the basic unit. The smallest shortcut leg that we can work with would be the short leg. In this case, it would be 1. The hypotenuse is double the short leg. Okay, so if the short leg is 1, the hypotenuse is 2. The long leg is the short leg times the square root of 3. Okay, so the long leg is the short leg times the square root of 3. That's what's actually happening in this picture, but it's, there's s's and variables, and you might be like, what's going on? So the short leg, hypotenuse is double it. The long leg is root 3 times it. Okay, so that's the 30, 60, 90 triangle. Let's do another example. So here, now I'm going to let gravity mess with you for a little bit. So here's the 30, 60, 90 triangle. How do you know? Because this is 30 degrees here. And if this is 30 degrees here, and this is 90 degrees here, this one must be 60. Okay? So what are we looking at in this triangle? We have the short leg. So if we have the short leg, we can find the other legs. Okay? So if the short leg is 2, the long leg then would be 2 times the square root of 3, because the long leg is the short leg times the square root of 3. And the hypotenuse is going to be, you guessed it, 4, because the hypotenuse is double the short leg. Okay? So that's another way of having that in practice. Not convinced? Let's do another example. Okay, so here's another triangle. Make sure we're going to be good with this, because I might be moving a little bit quick. So in this triangle, we have a 30, 60, 90 triangle. How do you know? Because this angle is 60. This is our 90-degree angle. This one must be 30, 30, 60, 90. Okay, in the 30, 60, 90 triangle, we have a lot of neat shortcuts happening. So what are we looking at? We're looking at the long leg. The long leg is 7 root 3. What does that mean? That means the short leg is something we know. If the long leg happens from the short leg times root 3, the short leg must have been 7. Right? That's the only way we're going to have 7 and 7 root 3. And if the short leg is 7, guess what the hypotenuse is? Good guess. 14. Okay? So that's how we work with the shortcut of the 30, 60, 90 triangle. The rest is practice, so let's do this, man! So let's take a look. A couple of examples. What we're going to do is find the length of each of these variables. So in this triangle, we have clearly a 30, 60, 90 triangle. We're going to find the variables. We have 5. What are we looking at with that 5? Hopefully what you see we're looking at is the long leg, okay? Not the short leg. That is the long leg. Hopefully you know the short leg is between the right angle and the 60-degree angle. That's the short leg. This is the long leg. So what can we find first? We can find first the short leg, and here's how. Remember how we get to 5 of the long leg. Whatever we have, the short leg, we multiply it by the square root of 3, and we end up with our long leg. Okay, so we multiplied the short leg times the square root of 3, and we end up with the long leg. Okay, so how do we find the short leg? The same thing we did in the previous lesson. We're going to divide both sides by the square root of 3. So the short leg then, our d, or length of d, is 5 over the square root of 3. Right? But remember, we can't leave that. We must rationalize the denominator. We have to multiply by our clever 1. Do you remember that from the previous lesson? If not, do watch the previous lesson, because that's going to be pretty important. The quick shortcut is what we talked about here. Remember this from the previous lesson. We multiply by a clever 1, blah, blah, blah. Anyway. We have to do the same thing right here. So we can't have a square root of 3 in the denominator. What do? We multiply by a clever 1. And in this case, the clever 1 is going to be the square root of 3 over the square root of 3. Okay? So our D then, our short leg is going to be 5 times the square root of 3 over 3. Now, in the previous examples with the 45, 45, 90 right triangle, we were able to simplify this, but this cannot be simplified. We have a 5 in the numerator, a 3 in the denominator, we're done. That is the short leg, 5 root 3 over 3. So the length of the short leg is 5 times the square root of 3 over 3. That is the length of the short leg. Okay? Now the question is, what about the hypotenuse? The hypotenuse is double the short leg. We're going to multiply this by 2. So here you guys got to be pretty darn versed on your pre-algebra. This is indeed pre-algebra concepts. We have 5 times the square root of 3, and we're going to double that. Okay, we're going to multiply that by 2. Well, what will happen? All we're doing is multiplying by 2 over 1, folks. Piece of cake. 2 times 5 is 10. So it's 10 root 3 over 3. That is how we double the short leg. Okay, and when we're dealing with crazy fractions, all we're doing is multiplying by 2. If this was confusing, because if this was confusing, you're not good with your pre-algebra stuff, make sure that you rewind and catch everything I'm saying, okay, because that's going to be pretty important. Anyhow, that is our hypotenuse now. It's 10 root 3 over 3. And that is as simple as we are getting it. So that's using the 30, 60, 90 triangle. But do remember the note. Okay, 30, 60, 90. Short side, hypotenuse is double. Short leg, excuse me. Short leg, hypotenuse is double. Long leg is short leg times root 3. Okay? On to this one. Boop. Next question. What is the value of A? Well, here's our A. Is it the short leg, long leg? What the heck are we looking for? Hopefully you know we are looking for the long leg. What do we have given? We have the hypotenuse. Okay. So the hypotenuse is 16. What do we know then? If we know the hypotenuse, guess what we know? We know the short leg. Because remember, the short leg is half of the hypotenuse. We doubled some number to get 16. So the short leg, we doubled some number to get 16. Right? So that's what happens. So what is the length of the short leg then? If we divide both sides by 2, the short leg then is 8 units. Okay? So that short leg there is 8 units, right? But that's not the question. The question is find the value of A. Well, if we know the short leg, folks, we know the long leg. It's 8 times the square root of 3. So the long leg, 8 root 3. Piece of cake. If you know what you're doing. Okay, so make sure that you are understanding everything from the note through this example. Okay? All right, 30, 60, 90 triangle. Fun stuff. Let's practice some more. So now it's all about jewelry making, because that will attract attention. All right, an artisan makes pendants in the shape of equilateral triangles. Any Harry Potter fans out there? This looks an awful lot like the Deathly Hallows. Very good. The height of the pendant is 18 millimeters. The height of the pendant is 18 millimeters, which means the elder wand is 18 millimeters. What is the length S of each side of the pendant? Okay, so we're going to be figuring out what is the length of the invisibility cloak. Okay, so what is the length of the pendant? We've got to find out S. So what are we looking at? It says an equilateral triangle. Here's a neat note you should know. If you're dealing with an equilateral triangle, you have 60-degree angles each. So if we were to click and zoom on this part of the triangle, we have our right triangle. We have an S here. The length here was 18 millimeters. What does this mean? It's equilateral. It means this degree measure down here is 60. That's what it means. And that's a very important meaning, because now we can solve the whole triangle. Okay? So we have 60 degrees here, 90 degrees here, must be 30 here, 30, 60, 90 triangle. All the good things that come with it happen. But what's the deal with the 18? 18 is the long leg, folks. Long leg. Okay? The elder wand is the long leg. So how did we get there? The long leg came from the short leg times the square root of 3. So some short leg times the square root of 3 gave us the 18. So how do we figure out what the short leg is? Divide both sides by the square root of 3. Okay? So question mark equals 18 divided by the square root of 3. Now, I am not going to rationalize this denominator, and you're going to ask, but Mr. Katz, because I'm reading the question, what is the length of each side to the nearest tenth of a millimeter? So I'm not using exact values, I'm rounding. So I'm using tenth of a millimeter. I'm not going to rationalize this yet, okay, because there's no need. I'll be using decimals in a second. All we have found is the short leg. We found here. Okay, so how do we find the long leg? We double it. Okay, so all we need to do to find the long leg is double it. So this would be 18 over the square root of 3 times 2. That would equal 36 over the square root of 3. And once again, I am not going to rationalize that because I'm rounding to the nearest tenth of a millimeter. So all I need to do is use my trusted calculator. 36 divided by the square root of 3. 3 square root. So 36 divided by the square root of 3 gives me this crazy number, okay? But what are we doing? We're rounding to the nearest tenth. Hopefully you know your tenths places. So in this case, this big number, 20.784, is going to be 20.8. That is how we round to the nearest millimeter. It's millimeter. It's 20, not that, come on, cats. 20.8 millimeters. That is the length of a side of the triangular pendant, or the length of the invisibility cloak. Anyhow, or was it the sorcerer's stone? No, the stone was the circle. Anyway, so we're good. Another example? Yes, please. Okay, last one, then we'll call it a day. Suppose the sides of a pendant in the shape of an equilateral triangle. Here we go again. Equilateral triangle. What does that mean? 60-degree angles. Okay, that's what that means. So the sides are 18 millimeters long. That means the sides now are 18 millimeters. So 18 here, 18 here, 18 here. What is the height of the pendant? Now the question is, what is the height of the pendant? So the question is now asking for the elder wand, right? So what is the height of the pendant? So that's the question. Okay, we have to make sure that we're reading carefully. The question is now, what is the height? So let's just take one particular triangle, okay? And here's our thing. We know it's a 30, 60, 90. So the hypotenuse is 18, right? The question is, what is the height? Well, this we can go pretty darn quick, because if we know the hypotenuse, we know the short leg. The hypotenuse is 18. What's the short leg? What is it? What is it? 9. Very good. Very good. And if the short leg is 9, what's the long leg? What is it? What is it? 9 square root of 3. We know that. Okay, but that's not the answer, so be careful. It's to the nearest tenth of a millimeter. So once again, trusted calculator. Okay, so we're 9 times the square root of 3. 9 times square root of 3, 15.5888. So what does that mean to the nearest tenth? To the nearest tenth. To the nearest tenth, you got it? 15.6 millimeters. That's our height, the height of the elder wand. Okay? Okay. So that's the 30, 60, 90 triangle. So hopefully you learned some stuff in this lesson. Look at everything we covered, right? In special right triangles. We got the 45, 45, 90. We got the 30, 60, 90. We found links. We did everything. Hopefully you enjoyed it, because we're getting into some trig next.